My name's Ian Stewart. I'm a senior front-end engineer on the UI infrastructure team at Arcesium. We're a financial technology firm located a couple blocks from Times Square. We have a software platform that targets the hedge fund market, and we have a pretty extensive platform. So one of the challenges that we face on the UI infrastructure team is enabling application-facing engineers to essentially do their job faster and easier. And the priority is that they should be ideally writing almost exclusively business logic and not reinventing the wheel when it comes to tooling, libraries, and when they follow the tooling and the libraries that we develop, it should lead them to the correct result. One of my favorite, I think our mantra developed by our SVP is the shortest path should yield the most correct result. Because down to the wire, when application developers have to deliver something, they reach for the closest pattern within reach to get it done. And if that pattern isn't going to lead them in a good direction, or if it's the best pattern is not also the shortest path for them, they're just not going to use it. So with that in mind, I've been looking at did a side effect layer comparison between sagas and observables. For reasons I won't discuss in this talk, went with observables, and my initial iteration was to proceed full observables, Redux Observable all the way. But I discovered, as the first time I tried to explain the approach to somebody else, that there was too much involved in getting that first CRUD feature up and running. And so, but Thunks everyone knows Thunks. And by the way, the baseline audience that is people who are thoroughly familiar with Redux. We're going to move pretty quickly. For those of you that are not thoroughly familiar with Redux, just try to gather some of the concepts and then review the demo app afterwards, because you'll be able to look over everything in detail afterwards. So what we came up with is Thunk and Observable. And you didn't know they could be friends. At least I didn't. Because the sentiment was, why can't I just use a Thunk for this? And then I asked myself, well, why not? Well, so we're going to move very quickly through this. It's not even to talk about observables so much. You're going to see them in play. But I just want to throw this up there. When I read a Stack Overflow answer by Dominic Denicola comparing observables to other async patterns in JavaScript. And this quote really struck me. Observables are a more refined version of event target. If anything was intended to replace events, it would be observables. And I think that's interesting because he wrote the precursor spec to the ES6 Promise spec, and he's involved in TC39. Now, observables do happen to be on the JavaScript standards track in TC39 on stage 1, so it could be interesting to know from that perspective. But I use them personally, so for that rigorous discussion, go there. But why I use them, they generalize features of both promises and event emitters. They're declarative, functional, and composable, so the big three buzzwords of the React community. But I think they legitimately apply. And they're cancelable, which is something that promises are not. So and what's cool about you can compose them by applying transformations along the way, such as map and filter. And if any transformation along the way chooses to cancel, then that chain is canceled. But hopefully we'll lower the barrier of entry to using them when you see really how simple it is, and especially simple when they are not part of the critical path of your application development, when they're not part of day one necessary knowledge to get productive. So let's take a look at this demo application. OK, here's this demo application. It's pretty awesome because it has one feature. All right, it's a YouTube search. Nice. So we can search for things like Infinity War, who dies? Nobody's watching that, right? I didn't think so. OK. Maybe DSLR video. And cool, we have results. There's a next button, previous button. Duration is a live filter. So let's take a look at what's going on in the console here. I've got some debug logging happening. So hitting search, well, first of all, we modify the search. That set query term is happening, and it has a payload of the query term. Hit search, search started, then search succeeded. Duration, is a set video duration event followed by a search. And next is a load page event followed by a search. So let's switch over here. See something familiar to those of us familiar with Redux. We have a trio of Redux actions that haunt us when it comes to boilerplate. And then we have some other ones, load page, the same ones we saw, set query term, video duration, enter. Enter is when this entire search layout mounts. We have to do some stuff. Here's our state, query, and results. So at any given time, when a search is created, it uses this query. And along the way, the user can modify this query with actions, such as set query term will set the query term, and set video duration will set the video duration. So there's no magic here. And then when a search of action is emitted, you have the start, success, and failure. So the classic trio with some loading state bookkeeping here. And so there we have loading and data. Pretty straightforward. Also what you would expect, Thunk rendition of search done manually. And we have load page. So this is sending the load page action, but immediately issuing a search with a Thunked dispatch that is embedding the page token and alongside the existing query. Same thing, set query term is simple, set video duration, it sets the video duration and then immediately uses the full query on the search. And enter does the same thing. It basically just launches a search. Now it's not a blank search, it's the search with these terms. And then, all right, so that's pretty simple. But we can do better because after writing your 50th Thunk like this, you're like, wait a minute, they all look the same. So we have some diffs for time purposes. Let's hope I can get this big enough. That's about as large as this will let me. So our first approach is to do something like Redux Promise, except we're doing it ourselves. And we have we're going to, let me find this. Yeah, right here. So here on the left is the Thunk done manually. Dispatching started, success, and failed all ourselves. On the right is the Redux Promise approach where we're dispatching a search along with a promise. So we are creating that promise in the action creator. That is a bit of a side effect. But this whole thing, there's less going on, and that's nice. Less boilerplate. And let's see how that works. Well, there's a simple middleware that's just a few lines that if the action has a promise property, then it will create first a start action, then and issue that, then it will issue an awaited result action, which will resolve to either success or failure. And we'll see these two come into play later, but if you want to take a peek, they look exactly like a templatized version of the Thunk we authored originally. So there's literally no magic going on. Okay, and a nice benefit now that we have a standardized API for async actions is we can eliminate the other boilerplate that we struggle with, and that's in the reducer. So because you can depend on these, take a look at this. We're now able to remove search started, succeeded, and failed because we're no longer hooking into those ourselves. That's being now handled in an abstraction that you'll see in a moment. But take a look at this reducer. Previously, we had started, succeeded, failed, all this repetitive code. We want it done exactly the same for every single async Redux request. And so why repeat ourselves? And not just for the sake of not repeating ourselves, but because with every repetition, we do it slightly differently. And with every feature, at my last company, we had loading in 5 different ways. In some places, we didn't have it. I mean, so you are not able to depend on in a really programmatic way what's in your state unless you're also assembling it in a really consistent programmatic way. And the way we're doing it is with this factory called an async reducer factory that it takes the base action that we care about and the destination property within the state tree managed by this reducer. So this is effectively saying, okay, for search started, for search when search success comes along, stick the payload in the results property. And I'll show you what that looks like. It is literally, there's no magic. It's a templatized version of exactly what we had going on in the reducer manually, but now this is happening for us automatically. And this could be composed. If you had multiple of these, there would be no reason why you couldn't continue passing the return value of one into as an argument of the next on down the line. And so boom, let's take a look at what this looks like in streamlined reducer. So let's go back to this reducer. Wow, that's a lot nicer. So this reducer is now lines 22 to 44 is the meat of it, where previously at this zoom level it was multiple pages. So it can all fit on the screen now. Also, action types simplified drastically. Actions, we've already we saw these in the diff, but I'll just call attention to it. Here is the search that is not creating a Thunk using Thunk manually. It's using our Promise middleware and creating a search action that is then later resolved by the middleware into the started, succeeded, and failed. And but we can do better than this, because if you notice, as a result of loading page, we are issuing an action and we're issuing a side effect. So there's a search here going on that is now a side effect of load page. Now for set video duration, it's the same thing. So it is for enter. And so this might be fine for this level of complexity, but start to think bigger, and now you're doing bookkeeping just to remember all the places that you're calling search from. Wouldn't it be nice if you could declaratively represent the conditions upon which you want to commit a search, and then map those conditions concisely to a search? That would be awesome, and actually that's exactly what observables do with the help of Redux Observable. So I can pull that up. There's a diff that shows exactly how much code is required to set up Redux Observable and these epics. In the first place, it's tiny. It's really straightforward. So there's actually a super concise set of diffs. These are all linked from the README if you want to check that out later. So let's look at, I think in this case, we'll just go straight to the code. Check out part 4. So let's go back to these actions. Now that we've introduced observables, we'll never touch again. Well, okay, I lied. We'll touch action types one more time, but we won't come back to the reducer. Actions, though, are tremendously simplified. These are all just about pure actions, with the exception that there is a side effect being instantiated from this search action creator. However, instead of instantiating the request and the promise within this action creator, you could imagine a alternative where you put here as at the call YouTube API and put some args, and then you have converted your promise into a description of a future promise by supplying like a promise factory and then some arguments besides. But that's beside the point. Just to say, if you're worried about this side effect that's still occurring, that can be factored out based on how you engineer your middleware, and there's something in the README about that as well, if you want to look at it. So the rest of these are all side effectless completely. They're not calling any other actions, which is super helpful. At least here, but you're like, where did the logic go? Because if it's not here, it's somewhere. Logic doesn't just vanish. And so, yeah, anyone can shuffle logic around, but the question is it cleaner where we put it next? So this is it, the big unveiling. These are the epics. Anything that's exported from here will be picked up in this root epic that is importing all of the exports from that file and then taking the object values of those, splatting them into the combined epics. So that's the wiring that I hinted at in that diff you can find in the README. But in here, all we're doing now is declaring the conditions upon which we care to execute a search query, and then as a result of those conditions, map to a search action. literally filter map. And if you've been in JavaScript at all recently, you've used filter and map on the arrays, on the array prototype. It's really, the whole point here is that this isn't scary. It's an optimization, and you get it immediately when you see it because it's filter and map. Making observables more accessible. Don't be scared by the $sign. That is just a observable way of saying actions observable. And if you notice that the $sign is like an S, so it pluralizes it because there's multiple. It's a subscription to multiple actions over time. So that's the $sign thing. There's nothing magical about it. And as before, these actions are mapped to a search query that's using the current query from the state tree that we see here. So that is being mapped. So every time you hit search, you're guaranteed that your search results will match what is in your query, which is important. It's deterministic and it's predictable. Sorry to throw those words out there. It's kind of buzzy, but load page epic is the only reason this is separate, and we don't have action type equals load page up here. The only reason it's not is because we do something slightly different. We do care about the payload of the load page action, so we differentiate it in this way by filtering out exclusively that action here, and then mapping that action's payload into the search query, just like we were doing earlier in the actions where we grab the argument, the page here. Instead of just gesturing, let me pull that up. So load page, page token. Before, remember we had two dispatches. We were dispatching the load page event. Then we were dispatching a search event where we mixed this page token in with the current query from the reducer using getState. But instead, now we just move that same logic over here. So nothing magical. And then, so let's take a look at this. And we're thinking, like right now, if we stopped right here, we have tremendous code organizational advantages by consolidating our side effects and only our side effects in the side effect layer. And yet those side effects aren't absolutely essential to getting anyone's job done, which is kind of cool. And it's a way that developers can incrementally understand observables by having an interesting, low barrier of entry. However, there is a problem. So this is a problem with all of the prior iterations, and it's a problem with, I'm sure, a lot of apps out there, including many of mine. So we're going to do something, introduce latency with, there's a backdoor here where we're going to slow down the paging request by 5 seconds. And that could present a problem, and we'll see that why in a minute. So let's go back to our DSLR video search. Page next. Oh, let's change our mind and go back to a blank search. Cool, we're back to the blank search. Or are we? So what happened was we initiated two requests, first paging, and then the generic search, then the general search. But the request that won was the last request to arrive, not the last request that the user initiated. And that leads to the cardinal sin of UIs: don't deceive the user. Because if this was a financial application and the user is a business analyst and they are presented with incongruent information, they could be making a business decision based on that information that actually has real world consequences. And so that's why we like determinism. The fact that we can't control network latency should make us a little nervous. Now, that's not to scare everyone, because that was a pretty intense like doomsday prediction of what can go on wrong with Thunk or something like that. That's not what I mean at all. So most of the time, like, your requests don't have massive race conditions like this. I mean, in order to have that kind of a race condition, there'd have to be some really nasty latency to occur between the two. So this was somewhat manufactured. So just to bring it down a notch, I'm not trying to scare everyone. But there is one last iteration that solves even this problem. And that is to use, I kind of like a little bit of saying we can go halfway, because this is the halfway. This is only using observables as an event orchestration layer, similarly to how you might if you were using an event emitter and then mapping and then listening for events and then emitting new events. But if you want to control the life cycle, the entire life cycle of these events, including the termination in the succeeded state, then you have to bring the entire mapping from the initiation of that event all the way through to the success or failure state into your observable epic, into your observable chain. Because when an observable chain has access to the entire mapping, then that's when some really cool features of the observables kick in. And let me just show you instead of talking about it more. Part 6. All right, so when I click, we're going to see the only additional user code necessary to go full observable with this. So there and down to there. So 2 things. If you remember these helpers from our Promise middleware, well, they're back. And now that's because we're taking over inside of the epic what the middleware was doing. So now we're mapping an action, these actions, to a start action, the same as the Promise middleware previously was using this helper to create a start action that it would dispatch. Now we're dispatching the start action, but only by wrapping our previous code with that one call. And the same thing for load page epic. So this is creating a start async action. Now what's happening when submit search, set video duration, or enter, that is one thing now. The view layer is not calling search directly. It's now saying, hey, I'm submitted, and now this is responsible for creating the search. So that is important. You want all your calls to search to be here, not anywhere, including the view layer. But now on submit search, set video duration, or enter, we are creating a start action. Same with load page. That will also create a start action. So imagine all the start actions just merging together and in the order that the user initiated them. Well, that's exactly what is happening here, where we're filtering for all of the search actions. And that helper creates on the started action a little source type property, so you can identify the started action based on the original, the base action. So this says this is the started action initiated by the search. And so what this does is it filters all the started actions in the system. Just to demystify this, we could just literally search started. And I think I was using namespacing. So literally, if you get the search started action here, then pass it to something called switch map. And this async action, it's the same result async action we looked at earlier from the middleware. This is an async function. It takes an action, and then later on, it resolves to either success or failure. So there's no magic there either. What that function does, it's a mapper from a started action to a result action over time with a promise in the middle. But we're going to introduce one new API method, and I'm realizing that's low, called switch map. And what switch map does is it takes an input stream, and when the callback maps a value from the input to a promise, it creates the promise but then keeps it on the side. When that promise resolves, its resolution value will be emitted by this map. So it's literally an asynchronous map. But the trick with switch map is if a second event comes along before the first promise resolves, it drops that first promise. It cancels it immediately. And it doesn't just drop it and ignore it. It actually sends a cancel chain through it and through that promise. Well, and so here we come back. Promises are not cancelable. But let's say you weren't using a promise for this. You were using an XHR object wrapped with an observable, or using, instead of fetch, you were using rxjs.observable.ajax, get users. So literally, I mean, the differences between these APIs are pretty marginal. They all let you create requests. But the difference is fetch returns a promise. This returns an observable, which is cancelable. And when this observable is canceled, it actually will cancel it at the browser level. And you'll see cancellation notices in your network tab for that same case. And the cool thing is, you don't have to be scared that that's an observable because I forget the exact location on the object it is, but to promise it's possible because observables are a more generalized version of promises. Don't quote me on that because that's not exactly true. It's more and it's different, but you can simplify it by thinking observables as a generalization of promise. So you can derive a promise from an observable and capture, I think it delivers the first value from the observable, and that's fine. But you can't convert a promise to an observable and retain the cancellation mechanism. So you could wrap an observable around a promise, which is what this is doing, but all it's doing, it's ignoring the result. It's not actually canceling the browser request. Anyway, that was too in-depth, I think, but for that was just a tangent. But anyway, the bottom line is switch map. With this final switch map will discard promises that are pending when a new action comes through, and that is exactly how it was able to ignore the fact that the page request came through a few seconds after the search finished. Here's some references and links. Check it out. Here's my information. The demo app's available.